Hi everyone, CCF here. Got a better video for you today, bit of a success story. I don't know whether you noticed in the comments, but a lot of people have been telling me, oh, move to Linux, get away from Windows. And as you know, I've had harvester problems because the harvester is running on Windows with compressed plots to C7 level, GPU harvesting, and there is a bug. Comes up every now and then. I've seen a lot of people complaining about it on Discord, on like Spacepool, where it just takes out the GPU and you don't get any partials sent to the pool, and unless you spot it early, it takes a massive nosedive on the chart here and just drops like a stone. And the only thing to get round it is to, of course, reboot the whole machine and start afresh, and you get 2 or 3 days grace until it happens again. So having knowing that harvester has got to move to Linux, because apparently you don't get the issue with Linux, it's only a Windows Bladebit compressed plot problem. I needed to do some investigations into Linux and how I was going to change my file, change the OS on my complete file. So first thing I did is I downloaded an OS called Zorin OS, which I put onto an old laptop I bought just purely to have a play around with it. And I use that for diagnostics and just monitoring, bit of email and browsing, pretty much that. Didn't seem to be the right candidate for converting the harvester and the plotter, but heard a lot of good things about Linux Mint, and they weren't wrong. They weren't wrong. Now I did decide to leave the harvester alone at the moment, leave it stable just so that the harvesting operation is continuing. I didn't want to use that as my test bed, but I was quite happy to do it with the plotter. So as you know, this is an old Dell what is it, a 5610 dual CPU, really old, very power hungry. I've got a GeForce RTX 3060 Ti in there, and 2 1TB NVMEs mounted in PCIe slots. So that's the harvesting machine, and with that, the max I could get was a 25-minute plot time, which, although a lot better than what I was getting this time last year, still not brilliant, and with electricity costs, something needed to be done about that. So what did I do? Well, I did a bit of investigation. People were talking about Linux Mint, and I decided, right, let's just get rid of Windows off this machine, put Linux Mint on, and see what it can do. Now there was quite a lot of configuration to do, and at the end of this video I'm going to go through exactly what I did to set up this machine and get it working, because there were a lot of little niggles here and there, and it would be useful information for you if you're planning on doing something similar. Obviously this is only, what I did is only going to work on this particular machine and this particular graphics card, but it might be portable to other setups. So I'll give you all the information I can about what I did, and hopefully it can help you out if you decide to do the same. So Linux Mint, what timings am I getting for a plot on here? Well, I had heard that they were going to be around this time, and they didn't disappoint. I mean, this was quite a long one, 5.92 minutes as opposed to 25. So I was really pleased with that. Astounding. Shame I didn't do this before I decided to replot the whole farm. I should have listened to advice from certain people who said it's not a big job to do, but I delayed it. But at least now I'm in a better place to continue the growth of my farm and replot a lot quicker, which probably will have to do at some point in time, before the next halving. Who knows, maybe even earlier. But yeah, sub 6 minute plots. I mean, I have had some less than 5.5 minutes, so really good. And that's using the Bladebit Cuda software. And as I said, I'll show you how to download that, where to get it from, how to configure it. And of course, the first thing I did, I created just a single plot on the machine. I didn't want to introduce Plough at all at this time because I haven't got spare hard drives. Didn't want to go through all that because there is quite a lot of configuration for that. So I thought I'd make a whole separate video for Plough when I introduce it. But for now, I just manually copied that single plot to a space that I had on OneDrive on the harvester, just to see if it registered and to see if it was, making sure that it was compatible. And yes, it was. So that part of it was quite easy. The plots it creates can be transferred to a disk that can be read by a Windows harvester. Not that we're going to keep that for very long. But anyway, enough about all that. Let's go and have a look at where I got this software from, where I downloaded Bladebit Cuda from, the various bits of configuration I had to do, and where I'll be taking it next.
Okay, let's have a look at some of the notes I've made about the upgrade path. I've tried to put as much information as I can in, and we will switch to the various websites where I got content to perform this upgrade, so hopefully it'll help you. But one thing to bear in mind is that this upgrade path was specific to the Dell T5610 PC that I was upgrading, which has 128 gigs of RAM and had my 2 internal 1TB NVMe inside and the 36D Ti NVIDIA graphics card. So yours may or may not be similar. It all depends on the architecture of your PC, but we'll hit those areas and we'll talk through those as we get to them. So the first part of this has to take place on another PC. For me, it was a Windows PC. It could be different for you, but the instructions will be very similar. So the first thing is to go and get the version of Linux Mint that we're going to install, and this is the 21.3 Virginia edition that I used, and there are a number of flavors of that, and I used the Cinnamon edition Edge version, and I'll explain why I did that in a second if we go to the site. So from linuxmint.com, here is their main page, and you can see 21.3 is their latest download. And you can click the download button and it takes you to a screen here and shows you all the different versions that they have of Linux Mint. So there's their main edition, which is just the plain Cinnamon edition, which they describe as sleek, modern and innovative. That will probably be the default if you're just installing on a laptop or a PC for home use. There is a lighter version available, probably for older hardware that can't handle it, and that's called the XFCE edition. Then they've got a sort of classic traditional version they call the Mate edition. And then there is the Cinnamon edition, the Edge version, which I used. And the reason I used this is because it explained that this has been specifically designed for newer hardware. So I wasn't sure if I was going to upgrade my GPU at some point in the future to a newer version of what I've got. So I wanted to make sure I had an OS that could handle that. So this seemed the ideal option for me. It may not be for you, but you've got several options there that you can choose from. I went with the Edge ISO. So you download that with the download link, and there is various mirrors here. So I just chose the one that was closest in my country, which was one of the UK ones down the bottom here, the UK fast one, and that'll download the ISO file and you can put it somewhere safe on your computer. I suggest making a folder because you're going to put some other files in there, and I'll explain what those are for in a moment. So once you've downloaded that ISO file, there is a SHA-256 sum file to verify the ISO file, and there's a whole procedure for checking that the ISO file you've downloaded is a genuine one supplied by Linux Mint. And the reason they do that is because it is possible to intercept traffic and feed in another ISO file to your download request, something from a nefarious group. So you want to make sure that the one you're downloading is definitely the one that's come from the website. And so these verification files will help you with that. So once you've downloaded the ISO, you'll come back to this area here, integrity and authenticity. And there are two files here indicated by buttons, this SHA-256 sum.txt file and a .gpg file. Now you need to download these, but you need to download them in a specific way. And and there are instructions for how to do that, and I think it's on this verify button here. But you right click those, you go save link as, and then you choose a destination and put it in that destination. As you can see, I've previously downloaded it here because I've already gone through that verify process. And you do the same for both of those files. Right click and save link as. And then the next thing to do is obviously to do the verification procedure, which if you click that button takes you to a screen here. There's various instructions here for if you're doing it on a non-Windows platform. But because I was doing it on a Windows platform, there is a link here somewhere. If you're using Windows, follow the tutorial how to verify the ISO image on Windows. So I'll open that in another tab so I can show you how I went about it. I'm not going to go into too much detail here, but if you follow these instructions, it's very simple. It gives you some various command line code to run, and tells you exactly what you need to put in and what you're expecting out from each of the statements you put in. And what you're looking for is basically for one of these commands, I can't remember which one it is, will feed back a fingerprint key, like you can see here. And in that .gpg file that you downloaded, it will have that fingerprint file so that you can verify that they're the same. If they're not the same, something has happened, something nefarious has gone on. You shouldn't use this ISO file. But that's the procedure basically. And once you've verified it, you're fine to go on to the next step. And that next step being to flash that ISO file onto a device that you can then install on your destination PC. So for me, that was a USB drive. I think it was a 32 gig USB drive I had that could accommodate the install quite easily. So I obviously formatted that first, got that clear, and then I needed to use something that can burn an ISO file in a usable format to that device. And there are many options to you out there in the world. I prefer using a product called balinaEtcher. It's a free tool for burning ISOs to devices. I've used it many times for many different things. It just works. It's very simple, very easy interface to use. You cannot go wrong. You just choose your ISO file off of your PC. You choose your destination device, your USB drive. Click go. And it does it, and it'll verify it at the end and say, yes, that's fine, and you're good to go. So balinaEtcher is very easy to get hold of. You just go to etcher.balina.io, and here you can see they've got the interface. This is as simple as it is. Select the ISO image, select the destination drive, and go. Flash it to the drive. Very simple. It's a free tool. Just click the download and get it. It's a very popular tool as well. A lot of people use it, especially in the crypto mining community. So you know, there's no problems with it at all. So once you've done that, you're now ready to go over to your destination PC, which may or may not be wiped already. Mine wasn't. I still had my Windows platform on it. But I decided I was going to get rid of that. It was time to say goodbye. I was having so many problems with it. It was time to move on. So the first thing I had to do before being able to install Linux Mint on, I had to go into the BIOS of that machine and say that I wanted my bootable devices to go from USB before hitting the internal hard drive. So it would search for a USB drive, and if something bootable was on there, would boot that first. It's a pretty old machine and it's in the BIOS. Sometimes you have to go into Windows and you have to do something like, is it ESFI? I can't remember exactly. I haven't played around with that area of it. I was able to do it from the BIOS. You might have to do some investigation if you hit problems, but have a go anyway. So once it's bootable, it's just a question of putting that USB drive into that machine, powering it up, and you should get your ability to press whatever key your particular piece of hardware supports to break into the boot list. On mine, I think it was function F12, and that then presents you with a list and says, right, what do you want to do? Do you want to boot from this USB drive that has this ISO file on it, or do you want to continue and boot from the drive that's got the current OS on it? So obviously you choose the USB drive, and it will then start the installation. One thing I would say is that it seemed to be quite slow. Might have been my USB drive, but I had to be patient before I got an interface saying, right, here is Linux Mint, what do you want to do? And I don't know if there was an option to install directly. I don't remember seeing one, but I chose the option of starting Linux Mint, because what it can do is it can install it into memory and allow you to see the OS and explore it even before you install. I know a lot of Linux distros do this. So that's what I did. I said start Linux Mint. Linux Mint came up, and I could see the interface and see how it worked before installing it. And very handily, there's an icon on the desktop, just one single icon that says install Linux Mint for when you want to start the installation procedure. So I went through that, installed Linux Mint. The only thing I had to be very careful of is because I had two internal NVMEs, that one of those was chosen as the default option to install the OS on. So I had to switch that to my SSD, which had the current OS on. And of course then it says you've got Windows on here. Do you want to install it alongside as a partition so that you can choose between either operating system? You may want to do that. I didn't do that purely for space reasons. This SSD only had 240 gig on it, and there were issues with the amount of space that was needed. So I decided to wipe it and put a clean install of Linux Mint on. And this didn't take very long at all. And the machine obviously decided that it had to reboot after the install. And obviously during the installation you have to do things like set up a name for the computer, a name for the default user, and a password. So once you've done that and it's installed it, you'll get asked to log in, and then you'll be presented with the operating system. All went very smoothly, no issues at all. Normal sort of things you get with an operating system install, asking, what's your locale, country, keyboard choice, and things like that, language. So that bit went without a hitch. And then the first thing that did happen, and I'll just call up the screen again so I can give you an idea. If you can just see here on this sort of example. Oh, it's not going to let me get it any bigger, is it? Down in the system tray, down in this corner here, there are a number of icons, your standard sort of stuff, your audio, your network. One of them is updates, OS updates, and that's the first thing you must tackle. Although this download is fairly new, there were some additional bits and pieces that it had to update. And so that's the very first thing I did, is went through that and applied all the updates. And this was a sort of multi-part process. It did the first set of updates, needed to reboot, and then it came back and it said, right, so you've got an NVIDIA card here. Previously there was a default driver installed that's not ideally suitable. I recommend you use the latest NVIDIA driver, and it gave that as an option, and I installed that. That went on, and then it said there were some libraries that couldn't be updated, so I had to do a further reboot, and when it came back, all was good, all was done. So that wasn't too bad at all. Very, very painless process, really. Didn't have any issues there. Yeah, so that's that first part there, updates and the NVIDIA drivers. The next thing to do was to install the CHIA Networks Bladebit. This is what you have to put on to the machine. It is quite a nasty process, but Fortunately, they've done a very good guide on the website of how to do it, and I'll show you that now. And once that's on, you can then go and get the Cuda toolkit from the NVidia site, which is required before you can install the Bladebit Cuda program support. So let's have a look at where you get the CHIA Network Bladebit software from, and that is here. So this is on GitHub. This is where the repository is for this CHIA Network, CHIA-network/Bladebit. Very easy to find. Here's all the code, but very handily underneath you've got some good instructions on how to apply it, and it tells you you know, the fact that you need a certain amount of VRAM for certain types of setups. I think my VRAM requirement is 8 gig for my 3060 Ti on my 128 gig system. But what you need to go down to is this bit. So ignore the fact here it says 256 gigabytes of RAM are needed for GPU CUDA plotting requirements, because we know there is a hybrid version that will work off 128 gig for me. You might have a full 256 gig of memory. It'll be a much simpler process for you, but my 128 gig system did very well, as you can see from the plotting times. So we can go past all of that, and then we can look at the prerequisites here. So this is all taking place on your Linux machine now. There is a button in the left hand side of the OS, which I can't show you unfortunately because I'm on a different machine now, that allows you to run a command window, very similar to Windows, where you can run all these shell commands. And there's two options here for the prerequisites. I ran the second set here, reason being that the underlying architecture of Linux Mint is Ubuntu based, and we'll see that in a little while when we go to the Cuda Toolkit download. But this is the command you want to run, and make sure you get it 100% right, and there shouldn't be any issues. Execute it and it will perform various installs. To put the support on, it needs to move on. We can skip over Mac OS and Windows because we're not dealing with that. And then the next thing to do is to actually build the Bladebit software from that Git repository onto your Linux machine. And there are four commands that you've got to run for that. The first is to clone the repo and the modules from the Git repository. So what this is doing is saying I want you to clone the Git repository that I've given here, which is the bladebit.git repository. And then I also want you to change directory to the Bladebit directory after you've done that. So you execute that one first. Excuse me. Once that's done, it'll take a while, but you'll see a lot of information go by on the screen as it installs various components, but you should end up with a command prompt where you are actually in the Bladebit directory at the end of it. The next bit is to create a subdirectory called build and make the build into it. Make a directory, build, and then change directory to build. So you execute that line, and next there's generating the config files and performing the actual build itself. And this is using the cmake command. So this target bit here, that's the target directory to install this in, and this is the type of config, it's the release configuration that it's going to build. So once you've run that, you've got on your machine the Bladebit software. Once that's completed, it will take a while, and you can verify that it's all there because you can go to the file system icon in Linux Mint, which once again is down in the bottom. Bear with me one second. down in this left hand corner there's a little folder, little yellow folder icon. If you click on that, it brings up the file system, and you'll be able to go to home, and you should be able to see then there's a new folder called Bladebit on there. That means your installation's been successful. Excuse me, it's very dry in here. Should have brought a bottle of water up with me, but never mind. Where do we get to here? Okay, so that being done, it then moves on here and says this is how you can talk to Bladebit. But we don't want to talk to Bladebit because we're GPU plotting. We need to put support on for Bladebit Cuda. And before you can do that, you absolutely have to go to the NVidia site and get the latest Cuda toolkit and install that. And that's from here, that's from developer.nvidia.com/cuda-downloads. And we've got a target here of Linux. Don't worry about all these URLs that I've been showing you and going to here. You don't have to remember them, you don't have to try and read them from the screen. I am going to put them in the description with the order of the presentation so that you can see where you have to go to get each component you need. So on the NVIDIA site for the Cuda toolkit, their latest version is 12.4 and you get some options here. You get Linux or Windows. Obviously we're dealing with Linux, so you click that and then you get a choice of architectures. Now your architecture most probably will be different than mine, I don't know. Mine is obviously x86-64. Yours you might have an ARM machine or something like that. Obviously you have to go a different path, but I clicked on x86-64 and then it asks for what type of distribution, and because Linux Mint's built on top of Ubuntu, that's what you choose here, Ubuntu. You then get two version options, and the version we're using is 22.04. Now you can get this from the Linux Mint documentation on the website, but you can also find it on the operating system itself. If you go to the system information area off of the main menu, it gives you a pop-up screen that tells you everything about your hardware and the software that you've got installed on it, and you'll be able to track on that in the software section and see that underneath Linux Mint you have 2204 Ubuntu support. So you click that and then you get what type of installer you want. Now this is where I didn't have a clue what to do. Not being from a Linux background at all, I didn't know. So I went for the middle option. I have no idea what the other two do, but I just know the middle option worked for me. Deb Network. It does tell you, if you just hover over it for a bit in the little pop-up, that it might take a little bit more time because it's not actually downloading an installation to your machine for you to run, it is doing it over the network. So it's not repeatable as such. But I didn't have any problems with that at all. It downloaded that and it put that on to my machine. And that it is very important you do this at this step. If you try and install the Bladebit Cuda application support before you've got the Cuda toolkit, you will just get a load of errors when you try and install it, because it won't have the libraries it needs to make the Bladebit Cuda application. So do make sure you get this before you attempt that. Right, so we've done that bit. We've installed the Cuda toolkit. Now we're going to install Bladebit Cuda support. And this can be done in one of two ways. The first way, if we go back to the where is it? The GitHub here. The first way is to do, where is it? I've lost that bit. Where is that bit? Ah, yeah, here it is. This is the section I was looking for here. Now you can do it by doing a similar sort of set up to this, but there was no instructions on it, and I was totally lost as to how to do it. But for simplicity, in the Bladebit directory, I think in the build folder, there is a file called build-cuda.sh, and this contains all the information and the code that is needed to put Bladebit Cuda support on your Linux machine. So all you do is you run that script from the command line. If I remember rightly, I think it's just /build-cuda.sh, and it then executes it from the build directory that was created underneath the Bladebit directory. So hunt for it or search for it, you'll find it, and as long as you're in the command window, you're putting the correct path to it, or you're navigating to the directory it's in, you should execute it fine. This one takes quite a while. It goes through a lot of sort of script, library builds, updates, whatever it's doing. A lot of information flies by on screen, and it doesn't look at first sight that everything's going according to plan, but it is. There are just a lot of warnings in the code that are echoed to the screen where it has problems with variables. Don't worry about any of that. Obviously, if errors are occurring, different matter, but the warnings seem to be perfectly acceptable and don't cause an issue. So that should be quite straightforward, and you'll have that CUDA support now. Okay, moving on to the next part. Once all that's on your machine, I'll give you my example here. It may be different for you. You might not have internal NVMEs like I have. You might have SSD drives. Your setup might be different. But obviously, before I can use my two internal NVMEs, I needed to mount them. And this looks like something you have to do in Linux. You have to mount the references to the drives before you can talk to them. And the way I found this out was the hard way. I tried to format the Bladebit Cuda CLI call and call it, and it immediately said, "I'm sorry, I can't talk to your drive you're asking me to talk to." So there was a clue there. Now mounting is fairly simple. Once again, from that little yellow folder icon in the bottom left hand corner of the screen, if you run that and get a view of the file system, under the devices section you'll see a list of your internal drives, SSDs that are available to you. Mine by default showed my two internal NVMEs, both with the original name that I'd given them in my Windows platform, so that had obviously been stored on the, I don't know, in the flash memory of the device. I don't know how, but it had retained those two names. And all you do is right click on each of those devices and you get a mount option, and as soon as you mount it you get a desktop icon referencing it, which you can double click and see the contents of it. So I did that for both those drives. There is also an option to unmount them, so you right click them and you can unmount them, which removes the desktop icon and unmounts them so they're not available anymore. But they have to be mounted before you can use them with the Bladebit software. The only other issue I had is that when you're referencing the devices, the NVMe from your CLI command, which we'll have a look at in a minute, you don't reference it with the device name, you reference it with the path which is on the properties of the device. So once you've mounted it, if you right click on the desktop icon it's put to reference your NVMe and look at the properties, you'll see it on the pop-up, a path. Now mine was, it was the name of the PC /media and then another device name that represented it, and it's that you have to use, not the actual device name itself. You have to give the physical path and the device name that's on the properties. So that was fairly simple. I didn't have problems with that. I had problems the first time round, so yeah, that's why I've put in the troubleshooting section here that you need to check they're mounted before you try any operations and make sure you're referencing them correctly. So next we could have a look at the Bladebit Cuda call, which you should be able to run now that you've put the support for all the software that's required. And there are a few examples down here for Bladebit Cuda. So once the Cuda application has been installed, you'll have to make sure your CLI shell is at the Bladebit build-release folder, if I remember right. Once you're in there, you can then call Bladebit Cuda. Now what I did initially was I just put simply that without any of the parameters, just calling the application without any parameters, because it's sort of standard practice for programs to say I'm missing what information I needed. So I knew it wasn't going to instantiate the application, it was going to come back with some sort of error message, but at least I would know that it had called the application. So that's all I ran initially, was just /Bladebit_Cuda, and immediately it came back and said you haven't given me a farmer key. That's what it was looking for initially. So I knew, great, it's working, it's just not been given the information. So there are 4 options here. OG plots, portable plots, compressed plots, and then 128 gig disk hybrid mode, which is the mode that I have to run because I only have half the required memory. You will probably be able to run this one if you've got a 256 gig machine, but I had to run this one. And the format of it is Bladebit Cuda -Z and your compression level, which in my case was 7 for C7. Then -F and your farmer key, and -C and your pool contractor address. Now if you're not familiar with how to get your farmer public key, there is information you can get hold of. I think the command is chia.xc keys_show, I believe, will open a file and show you your farmer key, which you should not give to anyone. Be very careful when doing that. But your pool contractor address, you should already know if you're part of a pool. It's visible on the sort of main CHIA GUI application. Then after that, there's this Cuda plot for me. So I have to say I want you to create a Cuda plot, but I am running with -128 gig of the required memory. So this allows you to work with a system that's not running at full spec. -T1 is your directories. So your temp directory is your first NVMe, and your output directory is your final NVMe. Now, these could be the same if you've only got one. You're probably not going to get the same performance. It might be a little bit slower. With specifying my 2 NVMEs here, the first temp directory was used to store the .tmp file that was built up to create the final plot file, and the second directory was used for all the processing tables. So obviously that clears down once the plot's been created, but your plot file, final plot file, stays on the one NVMe drive. And I think I tried about 7 plots just to see this in operation, see where it was putting stuff, and I ended up with 7 full plots of 83 gig or whatever it was on the first NVMe drive. So obviously if you've got one, it's going to do the whole operation temp to plot file and all the table creation files on the same drive, and maybe slightly slower. The only other thing to remember here is they don't give you an example, but by default this command will only create one plot and then stop. To create more than one plot, you have to go up here by compression level and put -n and the number of plots you require. You're probably already familiar with that if you've been doing it on other systems. So that was it, and then I ran that command and away it went, and the various table creation statements that were coming up on screen were happening, and happening a lot quicker than they had on Windows. In fact, you know, the plot was created in a fifth of the time, you know, 5.5 minutes as opposed to 25 to 26 minutes. So that was all good. Yes, so the only other thing to mention is you could have problems with the NVIDIA driver update, as I explained. It might attempt it and say I've got other libraries that are using what I need to update and I can't do it. But ignore the fact it's come up with an error, ignore any error messages that come up, reboot, and it will sort itself out and all should be good. So the only other thing to think about, and I'm not going to cover it in this video because it's already getting very long, and I can't anyway for reasons I'll explain in a minute, is because you're using NVMEs now, and they're going to get filled up very quickly, hopefully sub 5 minute time frame, you've got a problem in getting those off and getting them off quickly and distributed to your mass storage devices. So there are scripts that can help with this. You probably saw from my other video when I was on Windows, I wrote a very basic PowerShell script to keep in line with plot creations, and because those plots were taking 25 minutes to create, the PowerShell script could cope with getting each plot distributed to either a network drive or a USB attached device very quickly before the next plot was created. But obviously now there's a different problem. These plots are getting created really fast, and the copy operation to get them off that NVMe to make space for the new ones that be created has to be very quick. Unfortunately, there is a Python 3 script available called Plough, which allows you to do that and will take the place of any Windows script that you had performing this operation. And the beautiful thing about this Plough script is it can distribute very quickly using sort of parallel threading to multiple devices at the same time. So if you've got a network storage device with 10 disks in it, you can set up Plough to say, I want you to get these plots and fire them off as soon as they're available to all 10 devices, and it will just copy across that suite of disks and keep going till they're full. So it's going to be a great script when I get hold of it and get some hardware, because I'm going to need some more drives to transfer these plots to. You need a minimum of 2, I think. One's not sufficient. You need at least 2 storage devices set up in Plough to manage the distribution of the plots quick enough from your NVMe. So I've got to buy at least 2 drives now for my empty Netgear ReadyNAS 2100 unit, and get those in there and ready to accept plots from Plough. But as I say, I'm going to complete another video on that because I've seen a lot of people asking online. They don't understand Python, they don't understand this script and how to configure it. It is very well documented within the script, but I will talk you through how to configure it for your storage devices and your NVMe excuse me, and get it running. So that's coming up in future. But I think we've tackled enough there for today. I'm worn out, I don't know about you, but I hope that's been of use. If you're going to tackle something like this, a few pointers in there, it might get you on the right track. From what I've seen of Linux Mint, I am very impressed, very impressed. It's a wonderful transition from a Windows system. I found it very easy to navigate and find out how to do things, and it's got all the usual sort of built-in tools and even some good applications like LibreOffice and that come as standard in it. Usual sort of graphics packages and things like that. So it's fully featured, and it looks awesome and it runs well. Very intuitive. I think I'm going to enjoy working with it, and I'm definitely going to consider installing it on my harvester at some point when I'm brave enough. As I said, I did look at Zorin OS as another option, and whilst that was good for my excuse me, for my laptop, my cheap low spec laptop, it runs fine on that for what I'm doing on there. I wouldn't have felt comfortable using it on my plotting machine, so that's why I've chosen Linux Mint. So I hope you've enjoyed that. Please do me a big service and give it a thumbs up if you did. If you're not happy, give it a thumbs down. I don't mind either way. And also please consider subscribing if you're not already, and hit the bell notification icon, because it'll let you know when I put that new video up on how to introduce Plough to your setup. But for now, I'll say goodbye.